Good afternoon, everyone. Thank you very much again for being here in my talk. My name is Zixuan Feng, and I go by Steve. I'm a senior PhD student in software engineering, advised by Dr. Anita Sama. And I collect data from open source software and analyzing using mixed research method, such as statistical analysis, large language models, to develop and validate theories about software engineering process and outcomes, aiming to answer questions such as how can we empower the distributed teams to develop software more efficiently? How can we use the technology to help software teams do more with less? So today I'm here to present part of my research about the open source glue work. This work is interdisciplinary collaboration across foundations, academia, industry. And first, I would like to thank you to all my collaborators to making this work possible. So, many of you are here for doing advocacy, marketing, public speaking. So you sacrifice your weekends, you sacrifice your evenings, the time with your families, not just because you love it and because it matters to the open source communities. But my question is, how many of you have ever been acknowledged for such kind of works by your community and organizations? Or are they equally acknowledged? So open source brings developers globally to build and maintain large and complex softwares. But its sustainability and success depend far more than feature commits. On the left side is the set of the survey responses that we collected from Apache Software Foundation. So in one of the questions, we ask participants, which of the following tasks did you start with the Apache? And we find that beyond the code contributions, many contributors began with other type of works, such as documentations, decision makings, creating website, event organizations. And on the right side, there is another study from our lab, highlight that 3 pathways through which people grow in open source. So we observed the different trajectories, including non-coding careers and the transitions from coding to non-coding roles. So, but here, my question is, other than the feature, commits, contributions, what percentage of your OSS work is actually acknowledged by your peers and organizations? This brings us the concept that we use to frame these efforts, glue work. So glue work describe the critical contributions that hold a project together and ensures its health and success. So this includes not only writing and maintaining code, but also marketing, advocacy, quality assurance, event organizations, etc. So this type of contributions are undeniable prevalent in open source, but yet they are often go unrecognized in open source because they are invisible, they are uncompensated, they are inaccessible, or some combination of these 3. So when this glue work remains overlooked, those doing it always being disencouraged and questions like, why should I keep doing this? When newcomers joining, if they fear of submit code or get judged by code reviewers, so other than the code, what kind of other works they can start with open source? For communities that they care about glue work, or managers, they want to acknowledge glue work, and the lack of clarity on some fundamental questions. So what should we acknowledge? Why should we acknowledge? Where and how should we recognize and acknowledge those? So those challenges then emerge in our critical project functions. So it weakened the overall community infrastructure. As the meme on the right said, like people often realize the glue work when it stops working. So PyWorks has shed some light on the fact that glue work is not just a set of extra. GitHub uses the GitHub event stream to list contributors who interact with the repositories. However, these are still limited to the GitHub visible activities. Similarly, the all-contributor project that allows contributors to self-nominate their roles, such as designers, documentation writers. But this system relies on self-nomination. And among projects who are using this bot, only 20% barely active on it. So there is no comprehensive study that helps open source to understand, to recognize, to support, to acknowledge it. To fill the gap, we are here to investigate it systematically. We took the perspective of a classic theory from social science called invisible labor theory. So invisible labor refers to the work that is culturally and economically devalued, under-acknowledged, or unrecognized despite its critical role in sustaining the communications and organizations. And they are connected to the open source. So socioculturally, in OSS, the hacker's mentality tended to prioritize the code-centric view of success. So this kind of cultural ideology makes many forms of essential glue work, such as communications, mentoring, or coordinations seems less important, unequally important, or even unneutral. So even maintenance work, like refactoring or dealing with legacy code, is often viewed as less important as the feature commits development. So spatially, many contributions occurs outside of those central and visible platforms, like event organizations, Stack Overflow. So because it happens in less visible or fragmented platforms, projects often can't see the labor. And social legally, OSS communities, they often lack of consistent norms or governance that are or mechanisms for formally recognizing or compensating those non-code contributions. For example, some glue works. So without those structures, glue work is easily excluded from acknowledgement and reward systems. So all of these three lenses guide us to systematically investigate the glue work in open source. So specifically, we then ask three questions. What type of glue work are there? How can they be characterized? What does the glue work leave? How can we track them? And how and where can glue work be acknowledged? So to answer these questions, to answer these three research questions, we conducted a series of empirical studies across different OSS communities, try to establish our findings as generalizable as possible. So we began with a multi-vocal literature review, which means we reviewed not just academic papers, we also reviewed blog posts across 50 OSS blog platforms. And unfortunately, we find very few explicit references, which also underscores the urgency of our study. So, and then we then organized a focus group discussion as OSS Summit last year, and followed by the interviews. And that part aimed us to develop a community-grounded understanding of the glue work, including its types and how people feel about glue work. And building on all of those findings, we then conducted two surveys, one at OSS Summit and another at FOSSY Asia, to validate the types of the glue work. And we had identified and check if there were more glue works that we missed. So once we established that typology of the glue work, we conducted additional in-depth interviews that are focusing especially on how glue work is acknowledged and recognized. So this phrase was carried out first within the Microsoft OSS project, such as the VS Code and TypeScript. So with those data, we gain a preliminary understanding of where can we track the glue work and how it can be acknowledged and recognized. However, we were a little bit concerned that those findings might be biased towards the practice because they are from large tech companies. So to address that, we then conducted another triangulation survey within the course communities. Thank you, Lance, for helping us deploy the survey and to validate the channels for tracking and acknowledging glue work in a non-corporate OSS context. And of course, we acknowledge that there is no study can capture everything, and we are here to try to cross-validate our findings as much as possible. With all of those works, which took us over a year, and as a result, we have developed a taxonomic theory of glue work in open source. So this is a high-level version. In total, we have identified 12 types of the glue work across 4 categories: code technical management, mentoring and support, documentations, and community management. So each category link to a trackable channels, and all type of glue work can be acknowledged and recognized through 3 modes. For example, announcement-based, documentation-based, and communication-based. So let us unpack it dimension by dimensions. First, let us walk through what glue work is and what type of glue work exists in open source. So, the characteristic of the glue work. So glue work is essential for project sustainability, as I've been emphasized many times. All of our participants constantly emphasize that glue work is a fundamental to keep project alive, to sustain the term momentum, and to ensure the long-term success. So even though these contributions are crucial for community building and project health, they frequently receive little to no acknowledgement. People say no one values glue work contributions. So what we want to do was to give an invisible work more structured language. So as we mentioned, we have identified 12 glue works and organized them into 4 themes, as I mentioned earlier. And I understand the text is small, but we have put our findings in a temporary random web page. I will explain it why it's on a random web page. If you are interested, I will explain the URL in short. So let us walk through this academic version of the taxonomy. So we can use the mentoring as an example. So this type of glue work involves providing guidance to peers through suggestions, recommendations, and support. So for instance, onboarding newcomers through mentoring programs. So this taxonomy also provided evidence that have been used for triangulation. For example, if they have been mentioned by academic literatures, whether it has been mentioned by blog post literatures, whether mentioned by our focus group discussions, our interviewed, and the responses of our survey validations. And this is academic versions, and just want to highlight the fidelity of our work, and more user-friendly is available if you scan this QR code for easier reading. So after understanding all of the types of glue work, I would like to briefly introduce the contributors' experiences and the impact of the glue work. So since we don't have time to go all of those in details, because as many of you are here for giving talks, for outreach, for doing marketings, already excellent examples of the glue workers. So glue workers promotes community engagement by helping contributors feel connected and valued. Glueworks sustains productivities, accelerating progresses, and support long-term project success. And Gluework also fosters inclusivity, welcoming contributors regardless their technical background, and creating a collaborative and supportive environment. And finally, it also supports personal growth, enabling contributors to gain new skills and advance their careers. One of the interesting findings here that in one of the surveys that we conducted at Open Source Summit, in addition to understand what type of Gluework they exist, we also ask participants to help us to answer which type of Gluework that they think has the most positive impact on the project sustainability. And mentoring received the highest number of the votes, The reason why you see they are the highest vote is only 20% because we only allow one option. So, and let us continue use the mentoring as a representative lens to take a close look how it shapes contributors' experiences in depth. So, we find that mentoring promotes community engagement. For example, mentors feel emotional, rewarded for seeing mentees grow, and 18% of the mentees in the Google Summer of Code later become mentors themselves at Google Summer of Code. So, and our findings also highlight that how mentoring sustains the productivity and project success by enhancing teamwork and inclusivity, while fostering the personal growth by helping mentors and mentees gain confidence and career opportunities. So, by the way, this work is regarding the mentoring has been published, and which is a guidance of the mentoring in open source. It listed the characteristics, it listed the challenges, impact, and strategies of the mentoring in open source, just in case you are interested. Yes, so let's go back to our taxonomy. So otherwise I can talk mentoring about whole day. To now we have learned that what is the glue work and what are type of glue work are there. But now let us jump because they are so important. We need to sustain them. So we need to understand where to track and how to acknowledge them. So on the right is the taxonomy for tracking and acknowledging different forms of the glue work. For each type, we have listed the channels, and we have identified for recognizing and acknowledgement. It's quite small, and it's just showing we have the proof, we have the evidence that these channels exist. People are using it, but if you're interested, the QR code is listed more user-friendly web page. And yeah, let's continue using mentoring as an example to walk through this taxonomy. So on the left side, the taxonomy provide the channels in tracking mentoring, such as on the left side. So this side is about tracking, and this side is about acknowledging. Sorry, it's kind of small. The tracking, for example, including the pull requests, and on the right side, it mentioned where it can be acknowledged, such as the public acknowledgement on the LinkedIn or Slack channels. And one type of glue work which has two rows, and the first row indicated that the channels for tracking and acknowledging have been validated through at least three resources. For example, including our interviews, focus group discussions, and plus the survey validations, while the white rows only mentioned by two data resources. So at this point, I have finished my introduction of the taxonomy theory of the glue work in open source. And we could help in clarifying the spectrum of the contribution and enhancing the visibility of the variability roles and the contributions of open source, and guiding the contribution pathways and facilitating recognitions and reward. So moreover, such taxonomy can promote inclusivity and diversity and support product sustainability. The taxonomy gives us a structured way to talk about the glue work. That's valuable, but especially for researchers like us, we can build on it. But let's be honest, taxonomic alone doesn't always translate well in the real life practice. We have heard this from the community too, like people don't need another abstract model and they need something actionable. So as a researchers here, we are not just here to unravel the pain and to give you a theoretical taxonomy. We are here for engineering the solutions. So to bridge the gap between the academic understanding and the practical impact. So our goal is to help community do something with our knowledge, with this knowledge, to track glue work, to acknowledge it. So we were wondering, are there any ways that we could automate the process for tracking and acknowledging it? So because we are not here for throwing another task to maintainers and managers. Hey, here's the list. You should do it. Find out how people are doing it and acknowledge it. That's impossible. And we take, so while we were testing the automations, we take one example. We first test, take one example for doing the test. We continue to use the mentoring because I really love the mentoring and they are very important. We use the mentoring for the first testing. And if we could use the machine learning to track the mentoring. So the reason we use the mentoring because it has been really most important. And we also find that tracking the mentoring is not that easy, for example, compared to documentations. So mentoring OSS can take many forms from the formal, like the code day, or informals. And for a lot of projects who does not have the access to the mentoring programs, the mentoring happens during the routine development activities, for example, the pull requests. Here we then define such mentoring as called implicit mentoring. So this work called implicit mentoring have been published that, and if you are interested, you can scan the QR code. Yeah, and the small table here shows how we define the implicit mentoring in the PR comments. So in order to showing that how can we use the machine learning to track this implicit mentoring, we first conducted data mining over 100,000 pull requests, which contains 800,000 comments across 37 Apache projects. And then we manually, based on the table you saw, we manually labeled 385 random instances as our ground truth data for our machine learning training. And we then use we trained in total 5 machine learning models. We find out the random forest performs the best overall. The red side shows the performance table and the confusion matrix of our random forest machine learning models. So on the left, it shows the results after we applied our machine learning models to the Apache pull request comments data set. We find that among those over 800,000 pull requests comments, 27% of the pull requests included at least one implicit mentoring comment, with over 63% of PR comment authors acting as implicit mentors. So this shows that implicit mentoring is widespread in OSS interactions. And on the right, we go back again to survey the Apache contributors to cross-validate the statistical findings from actual human contributors. Over 92% of the respondents agreed that our definition and the channels we use to identify implicit mentoring. So building on our identified implicit mentoring PR comments, we conducted a series of statistical analysis and static code analysis in order to understand the impact of the implicit mentoring. So this step was another way to validate that if earlier we mentioned about the impact of the glue work, if you remember this, or whether it happens for forestry engagement, project success, or whether related to the project personal growth. So what we find from static code analysis is that implicit mentoring reduces the need for formal guidance and enable contributors who receive the mentoring support to submit a more complex and central code contribution to the database. And for the mentors, we find that implicit mentoring actually helped increase their productivity and shaping their technical skills. Then our survey also indicated that 82% says implicit mentoring improved their technical skills, and 86% report their improvements in leadership skills. And mentors also benefit, including career growth, confidence, and social skill gains. So all of those were just one of the test case that we used the implicit memory as a proof of concept to demonstrate that the viability and applicability of automating, of tracking the glue work and acknowledge it. Now we need a comprehensive solution. So let me introduce the tool we are developing right now, which is LLM-powered innovation with a multi-agent design to recognize and acknowledge the glue work. So we don't have that much time to cover all the technical details about the bot here, but let me walk you through a user scenario to illustrate how it works. So meet Alex. She's a community manager for open source project. And Alex realized that glue work often go unnoticed, but she's overwhelmed with a lot of maintenance work and doesn't have time to manage the glue work. And a colleague recommended the glue work tracker to Alex, so Alex installed it in her project CI pipelines. And she began by configuring it, selecting the type of glue work that is relevant to her project, and uploading the necessary artifacts. Once set up, the tracker runs automated analysis, scanning these artifacts to detect the incidences of the glue work. So when complete, it generates a pull request with two files. One is called contributor list.md, which lists the contributors involved in the glue work, and another is glue work report.md, which details and quantifies their contributions. So Alex reviewed the pull request and approved it and merged the file into the project documentations. So from then on, the glue work tracker automatically reruns every week and updating the reports. So this tool is still under the development. We have not finished that yet. I just want to make a claim here. So this is just one of the millions of the ways. I understand we are using the AI to recognize and acknowledge it, but between acknowledgement and unrecognized, and also burnout maintainers, burnout community managers, AI is kind of the trade-off that we think we have found. Yeah, so quick say, so glue work is a quick summary. Glue work is essential, but often invisible. And OSS sustainability depends on the contributions beyond the feature code. For example, mentoring, documentations, community engagement, and more. And we have developed a theory taxonomy that identified 12 types of glue work across 4 categories. And we also offered practical pathways to trace and acknowledge of the glue work. Yeah, and we are developing the bot to automating the process. Yeah, and thank you very much again for your attention and engagement. As a wrap up, we are actually looking for the collaborators. So on the left, our goal is to make the findings from the glue work research not just academically useful. We don't want it to stay on the academic papers. We want to let it become actionable and visible to open source communities. So right now, our taxonomy and supporting resources are temporarily held on a random website because of the anonymization restrictions of the journal. So we can't publish anything relevant to our personal GitHub or anything. But in the future, if we are looking for OS communities who are interested in embedding this framework into their project website, so that it not stay on just on my personal website. And another thing is on the right, we are developing this multi-agent bot system, helping to automate the glue work recognitions. The system is currently under the development. We are looking for the open source projects interested in piloting and testing it in the real world settings. Yeah, and thank you very much.
Steve, you did an excellent job staying on time. We've got 15 minutes for questions before the break, so let's have it.
Yes, please.
You spoke a lot about recognizing the work of mentors. Does that show up in any sort of statistics that you've created? Or
Yes, you mean recognize the glue work
Yes.
of the mentors, the mentoring glue work? Yes, yes. So let me show you. Sorry, the text is kind of small. So if we record, so we trained the machine learning models to identify the mentoring instances happening in the pull request comments. So when people give the suggestions, comments, not just reject the pull request or saying looks good to me, giving like extra suggestions and willing to spend more time to educate the newcomers or peers. We call this implicit mentoring. Our machine learning models actually find that, 1 second. So on the, 1 second. Yes. I don't know where. Yes, here, yes. Yeah, our machine learning models, we find that there are 27% of the pull request contains such implicit mentoring comments. Yeah, people and implicit mentoring comments are very prevalent. And this is just a statistical data. In order to cross-validate and make the data more trustworthy, we went back to the Apache developers and let them to help us confirm if they actually did it, or if they agree with the definition of the implicit mentoring. And over 90% of them agree with definition of the implicit mentoring, and like 80% of them saying they have received such implicit mentoring, and over 70% of them saying they have given such implicit mentoring to their peers. Yes.
You're
Yes.
the boss. So you're the professor. Now. You call us students. You can do this.
Okay. I'll start with the closest to mine.
Wondering if you got any demographic breakdowns from your respondents, gender orientation, any of that, was there a diverse population in the surveyed people, or was it all concentrated in a couple of different classes?
You mean there are multiple surveys in our studies. We try to balance that as much as possible. That's why in order to identify the type of the I'm jumping. In order to identify the types of glue works, we are not just trying to get as many as possible. We try to cross as many communities as possible in order to, if we can make our findings as generalized as possible. Yeah. And our gender distributions are, I think it stays as among women is like 8%, women and women and the gender minorities are 8% versus 92% are men. Yeah. Sorry, you have some questions? Yeah.
So, in the benefits, like people think like, 80% of people like reported like benefits of being implicitly mentored, or
Yeah.
implicitly mentoring. Like, are these self-reports? Like, they're just like, I feel better about this, or were you able to find like statistically like?
Yes.
Generally go on?
Yes, I did both. Okay. In order to make my data strong. So first, we did static code analysis. We analyzed those people who have submitted implicit mentoring comments or who received the implicit mentoring the comments. From the mentee side, we find that there is a mentoring ratio decreased over time. So as a newcomer, you're joining, you receive the more mentoring comments, and as the at the time longer you are involved, the less mentoring comments you received, and we also find that the more comments, implicit mentoring comments you received, and the more line of code you contributed, plus the code centric is more like and the code is with higher complexity and more centric to the code to the code base. And this is a statistical data, And then we then also validated the people saying, oh, the implicit mentoring literally sharpened our technical skills, help us grow, and also including, also they are saying the implicit mentoring expanded their collaboration networks. Yes, please.
I was curious, since the focus of this research seems to be on the community kind of accrediting or giving proper credit,
Right.
and this kind of production focus on like, hey, here's these people doing this labor that's unaccounted for. Have you done any research on like the flip side of like companies or researchers trying to find out like, hey, here's the value of this labor? Because I've heard definitely last year a decent number of talks on software bill of materials, and it seems like this is also kind of adjacent for it, where there is hopefully some form of non-market way to show the value of this labor and this effort, and,
Right.
and like some quantifiable.
Yes, that's our next. That's our future work. So basically, because nobody have done that before, there's no empirical findings to investigate the impact of such works to the project health. There is no matrix for evaluating that. So our first goal is just to understand what type are they. If we can track them, then we can do the empirical studies to analyze it. For example, relationship between the impact and versus the project health, different governance models. Yeah.
I'd also be curious if there's like any kind of non-market valuation that you would lean towards when trying to do that kind of research, because I had this come up in like an environmental economics course, and all of the ways that I recall doing this kind of that people go about this is like, oh hey, there's like a park that's so many miles away, and then you can measure the time cost and see how much people value these public resources. And for like technology, it seems a lot more difficult because there's like this acquisition of human capital that you could probably try and evaluate as a time cost. But some parts of it are very costless.
Right. Yeah, that's a very good point. Yeah, we need to talk about more about that. Thank you. Yes, please.
I might have missed this, but can you give some more examples of what implicit mentoring is?
Oh, yes.
So, it's hard to see back here.
Yeah. Sorry.
Also, like, as somebody who's maybe new to an open source community, how they might ask for implicit mentor. Like, do you get any insight into how you might like solicit implicit mentoring?
How to? Yeah. So in order to how to ask questions, like you mean how to get the implicit mentoring comments.
Yeah, like I know that like with any insight into that.
Yeah. So first of all, let me introduce the mentoring. The definition of the mentoring that we define is a form of informal mentoring that occurs in everyday development, such as the code reviews, maybe also the issue reviews, and where the mentors provide explanations when providing suggestions, instructions, and a mechanism to address the error. So that means the explanation is the most important key part here. It's not just saying, hey, you are doing wrong, and we rejected your pull request, but giving the explanations why it's wrong, are there any resources you need to go, and how to fix it, giving the guidance. This is what we call implicit mentoring. And in the pull request, at least the sample here, it's kind of small, but if you scan this QR code, the paper has that examples. There are some examples for listing whether a pull request is giving the suggestions or giving the instructions or how to address an error, and versus just LGTM, right? Yeah.
And so, as a participant in an open source community, how would you recommend soliciting implicit mentoring?
Right. Professor Igor, he has a paper about how to ask questions. There's a template for newcomers for listing like how can you ask for help or newcomers when you submit a pull request. I will find the paper and send to you. Yes, please.
Do these implicit mentors, do they even know that they're providing mentoring? Do you know if that's the case, or Like, is that something they've recognized they're doing?
Yes, that's the thing. I think we never ask these questions, but most of them are just that they love the community. They love to help each others. They don't know they are doing it. No, actually, no. Yeah.
Yeah, that's very interesting. I know you've done some work in the past about like what people are looking for in mentors,
Yeah.
and what they want in the mentoring relationships, and I wonder if these people recognize.
No, yeah, even like they don't. That's why we are saying like we need to acknowledge them to sustain this
Yeah,
activity.
I wonder if you see these projects start to acknowledge it, I wonder
Yeah.
if that means people are going to want to do more of this mentoring.
Yeah, exactly. Yeah.
Very cool.
Matt, you got it.
Yeah, when we were talking about the like in progress tooling to help acknowledge, you mentioned that there's this like kind of trade-off, right? You don't like add something to a maintainer's plate or like another to-do item.
Right.
I guess did you like in the kind of validation or in like the conversations you've had, has the trade-off of saying like, hey, we're gonna implement a tool to do a lot of or like kind of automate a lot of this acknowledgement versus the maybe most like human meaningful thing of just having the maintainer
Right.
represent it. Like, do contributors or maintainers have any thoughts or feelings on like that trade-off? And
Yeah, I really like. Yeah, I really like that questions. So, in my 5-year PhD student career, I developed the 2 tools for open source, 2 dashboards. One is for diagnosing the state of the diversity, and we collaborated with Apache for that dashboard for evaluating Apache product state of diversity. And the other tool we developed is I present that talk in the first FOSSY to predict the contributors who is going to leave the project, so that maintainers or managers know, oh, this part of area may need help. I need to recruit more people. But those two are already like give you very like actionable strategies. You need to do something, and in addition to like, that's actually is adding more works to maintainers and managers. They are already super overloaded and they don't have time for another tool. And that's why in the very first time I mentioned that there is a tool called All Contributor Bot. You can anonymize yourself. You are document writers or you are designers. And all maintainers need to do is they need to approve the pull request, but they have to validate it. So even with this easy work, they don't have time. They are really overloaded. That's why I'm thinking like I should do a thing that is just like they only need to make action one time. Just they install it, that's it. If like they test it out for first a couple of weeks and ensure that LLM is actually doing it, and then they can just they don't need to go back to work on it. That's my goal.
All right. Well, thanks, Sweet again.
Yeah. Thank you. By the way, sorry, I have one more thing. Sorry about that. I need your help. Sorry. So, I'm asking a favor for this beautiful community to help me do one of my studies. So, do you hate AI? Do you love AI? I'm investigating the impact of the AI on the software development activity. This is a 5-minute survey. Please help for PhD students. Thank you.
All right. So we're up against the